Hi everybody, hope you guys are doing well. We are halfway through the week. This is Wednesday the 29th. This is the last lesson from April, and then we move into May, and we just have a couple weeks left. So exciting stuff. I don't know about you guys, but I feel like I am starting to lose track of the days. So yesterday, so I'm recording this on Tuesday night. Yesterday was Monday. And I was going like most of the day thinking it was like Saturday. So I'm like completely thrown off with like the days, and I don't know if you guys are thinking the same thing, but like the days are all just kind of jumbling together for me at this point. Really one of the few ways I can keep track of the days is like, okay, we got school Monday, Wednesday, and Friday, so that helps a little bit, I guess. And then church on Sunday, of course, but like, yeah, it's hard to keep track of the days, I feel like, right now when the days are starting to look kind of similar to each other. So hopefully you guys are doing all right. Let's go ahead and jump into this lesson. This is a continuation off of Monday's lesson when we were adding and subtracting rational expressions. So we are going to continue that today and finish that up. Okay, problem 3. Adding expressions with different denominators. So on Monday we talked about adding and subtracting expressions when they had the same denominator, right? You didn't have to do much, you just added the number on top, right? Now, to add or subtract rational expressions with different denominators, you can write the expressions with the least common denominator. So, it says here, what is the sum of 5 over 6x plus 3 over 2x squared? Now we can't just add these together because they don't have the same denominator. So you got to find out what the least common multiple is of 6x and 2x squared. Well, you can list them here like this, okay? Or you can think about like the coefficient. What's the least common multiple of 6 and 2? Well, 6 times 1 is 6. 2 times 3 is 6. Okay, so the least common multiple there is 6. Now look at the variables, x and x squared. What's the least common multiple of x and x squared? Well, x times x is x squared. X squared times 1 is x squared, so the least common multiple there is x squared. So our denominator that we want is 6x squared. Now we got to figure out what we need to multiply each fraction by so that we can get the denominator to be 6x squared. Okay, well, what we need to do is let me erase, actually no, so for 5 over 6x, how do I get 6x to equal 6x squared? Well, I just need to multiply it times x over x. So we're going to do, let me erase some of this pen right here. This first one, we're going to multiply this times x over x. Remember, you have to multiply each fraction by something that's equivalent to 1 in order for it to stay the same fraction. You can't just multiply it by x on the bottom, because then it changes the fraction. So you got to multiply it times x over x, because x over x is just 1, right? Now the bottom, or the second fraction, 2x squared, we need to multiply that times 3 over 3 to get that equal to 6x squared. Okay? All right, so let's rewrite this. Let me erase this here, make some room. 5 times x is 5x. 6x times x is 6x squared. That's what we want. Now it's plus 3 times 3 is 9, and then 2x squared times 3 is 6x squared. Now you can see we've got common denominators. Now we can add them, right? So 5x plus 9 goes on top, and then on the bottom we've got 6x squared. Okay? And this is our simplified form. Okay? Go ahead and see if you can find the sum here. Make sure you find common denominators first, and then add them together. Pause the video and come back to me once you're done. All right, so let's look at our denominators here. 7y to the 4th and 3y squared. So 7 and 3. What's the least common multiple there? Well, hopefully you know. That's 21, right? Then y to the 4th and y squared. The lowest value for y that we can use is going to be y to the 4th. Okay, y to the 4th times 1 goes there into y to the 4th, and then y squared times y squared goes into y to the fourth, right? All right, so we got to figure out what we're going to multiply each one by. So we got to multiply this first one. Let me erase these pen marks. 7 needs to be multiplied times 3 to get 21, and then y to the fourth doesn't really need to be multiplied by anything to get to y to the fourth. So this one we're going to multiply times 3 over 3. Okay, 3y squared then, 3 times 7, so we're going to multiply top and bottom by 7, and then y squared times y squared equals y to the fourth. So we're going to multiply this top and bottom by 7y squared. Okay, all right, now 3 times 3 is 9, and then 7y to the fourth times 3 is 21y to the fourth. Okay, now 2 times 7y squared is 14y squared, and then 3y squared times 7y squared is 21y to the fourth. So now you can see we've got common denominators. Now all we need to do is add. So we've got 14y squared plus 9. Remember, we're going to put this in standard form. You want the variable going first, over 21y to the fourth. And that's our simplified form. All right, second example, now we're going to subtract using expressions with different denominators. Okay, here it says, what's the difference? 3 over d minus 1 minus 2 over d plus 2. Now, this is a little bit different because d minus 1 and d plus 2, they don't have common factors. Okay, so step 1 is to find the least common denominator of these. There's no common factors, so basically what we have to do is just multiply them together. D minus 1 times d plus 2. The least common denominator is just going to be that. Okay? Rewrite each rational expression using the LCD and then subtract. So for this first one, this first fraction, we're going to multiply it times d plus 1 on top and bottom. So 3 times d plus 1 over d minus 1 times d plus 1. And then that's subtracting. Now this one is going to be times d minus 1. So it's going to be 2 times d minus 1, and then it's going to be d plus 2 times d minus 1. Okay. Now we're going to multiply. We're going to use the distributive property here. So 3 times d is 3d, and then 3 times 1 is plus 3 over, we're just going to keep the bottom as d minus 1 over d, oops, this should be d plus 2. You guys probably saw that mistake and you're shouting at your screens at me, oh, you made a mistake. Okay, thank you, I caught it. Thank you for your help. D plus 2, and then we're minusing. Okay, so one thing that's important to understand here, since it's minus, this is the same as plus a negative 2, right? So it's going to be negative 2 times d is, we're going to change this to plus, it's going to be negative 2d, and then negative 2 times negative 1 is going to be a positive 2 over d minus 1 times d plus 2. All right, now, since we changed this to addition then, we're just adding 3d plus negative 2d. I'm going to put this up here because I'm running out of room. That's going to be d, and then 3 plus 2 is d plus 5. Oh, you know what? Hang on. So I told you I messed this up. I forgot this needs to be d plus 2 also. So 3 times 2 is 6. This should be 6 right here. Okay, which means the 5 should be instead 6 plus 2, which is 8, over d minus 1. We're going to keep the denominator, d minus 1 times d plus 2. Okay, made a couple mistakes there, but we caught it. We're all good. D plus 8 over D minus 1 times D plus 2. Hopefully I didn't confuse you too much with all the small minor mistakes. All right, I want you to go ahead and try this one then on your own. Find a common denominator and then subtract. Pause the video. All right, so these two do not have a common factor, so you're just going to multiply this one by c minus 2 and this one times 3c minus 1. Okay, so c times c is c squared. C times minus 2 is minus 2c over 3c minus 1 times c minus 2. Okay? Minus, now let's do this second one, 4 times 3c. Actually, let's make this a negative 4. So we're going to do plus and then a negative 4. So plus, negative 4 times 3c is negative 12c. And then negative 4 times negative 1 is a positive 4. Okay, over, we're going to have our common denominator now, 3c minus 1 times c minus 2. Okay, and now we change the subtraction to addition, so c squared has no other like term, so it's going to be c squared. Then negative 2c minus 12c, okay, is going to be a negative 14c. And then we've got plus 4 at the end. And then that's over 3c minus 1 over c minus 2. Okay. And then also one thing that you can do is check to make sure you can't simplify this further. This top, can we factor that top? We would need factors of 4 that add up to negative 14. So our factors of 4 would be 4 and 1. That adds up to 5. And then 2 and 2 adds up to 4, right? So no, that can't be factored. So our final solution then is c squared minus 14c plus 4 over the quantity 3c minus 1 times the quantity c minus 2. Okay? All right, this is the last problem then. It's kind of a word problem. Okay, it says a certain truck gets 25% better gas mileage when it holds no cargo than when it's fully loaded. Okay, so when you've got, hopefully you guys can't hear my chair squeaking so much. Makes sense, right? When a truck is full of cargo, it's going to be heavier, so it's going to get less miles per gallon than something that's lighter, right? With something without any cargo in it, right? So a certain truck gets 25% better gas mileage when it holds no cargo than when it's fully loaded. So let M be the number of miles per gallon. M isn't the number of miles. M here represents the number of miles per gallon. Okay, the truck gets when it's fully loaded. The truck drops off a full load and then returns empty. So it's going somewhere, drops off its load, unloads it, now it's empty, and then it comes back. What is an expression for the number of gallons of gas the truck uses total, round trip, there and back? So step 1. Write expressions for the amount of gasoline used on the outward trip and on the return trip. So the outward trip, that's when it's fully loaded, okay? And we're going to use this picture here to get the total number of miles, right? So we're going 80 there, 80 miles there, and 80 miles back. So the distance traveled divided by miles per gallon should give you an expression for the number of gallons used. So you take 80 over M. 80 miles divided by M miles per gallon. Now on the return trip, it gets better miles per gallon. Okay, it's 25% better gas mileage. So if it's 25% better gas mileage, you don't do 0.25 times M, right? That's a fourth of the gas mileage. That's not better. We want 1.25 M to show that it's getting more. It's getting 25% more miles per gallon. So again, we're still doing 80 miles on the trip back, but now our gas mileage is 1.25 miles per gallon. Okay, now to get the total number of gallons that's used, we're going to add up 80 over M plus 80 over 1.25 M. Okay, now to do this, obviously we need common denominators. these, all we need to do here is multiply this by 1.25 on the top and bottom. So on the bottom, we're going to have 1.25 m. Now we need 80 times 1.25. Some of you can probably do that in your head, right? But let's go ahead and just do this in the calculator. So 80 times 1.25, that's 100. Okay, so we have 100 over 1.25 m, and then we're going to add that to 80 over 1.25 m. And we end up with 180 over 1.25 m. This is an expression we can use to represent the total number of gallons. Okay. You can also reduce this, by the way. 180 divided by 1.25. Okay, let's just reduce that. 180 divided by 1.25 gives us 144. So we'll say it's 144 times m. Gives you the total number of gallons. Okay? All right, what I want you to do here is I want you to go ahead and do this one on your own. A bicyclist rides 5 miles out and then rides back. So he's going 5 miles out and then 5 miles back. His speed returning is reduced by 20% because it's raining. Let R be his speed in miles per hour riding out. What is an expression that represents the total time in hours? So out, okay, he's going 5 miles, okay, and then we want the total time in hours, so we're going to do 5 divided by his speed in miles per hour. Okay, we'll let that be R, okay. And then back, he's going 20% slower. What can we use to represent that? Okay, we don't do 0.2R, okay. That's only 20% of R. That's 80% slower. What we want is 100 minus 20, or 0.8R. So we're going to do 5 over 0.8R. Right? If full speed is 1R, right? 20% slower than that is 1 minus 0.2, which is 0.8, right? So we want 0.8R. So now to get the total time in hours riding out and back, we're going to add these together. 5 over R plus 5 over 0.8R. Okay. So we need common denominators. We're going to multiply this one by 0.8 over 0.8. Okay. So 5 times 0.8, it's going to be 5 times 0.8 is 4. And then 4 plus 5 is 9 over 0.8R. That should be your solution then. Okay? All right, that's it for today. Hopefully you guys were able to follow along okay. Your assignment is on Math Excel, so the 11.4 homework. If you have any questions over this, feel free to shoot me an email and ask. Also remember that there is always the option of coming by on Friday. At 1 p.m. on Canvas, I will be hosting another live Q&A for you guys to come by, ask questions. You can stay for a minute, 2 minutes. You can stay for half an hour if you want. You can stay for the full hour if you want. Okay, but feel free. Make sure you're using that time to ask questions if you have them. I don't want you to feel like you're all alone right now trying to do this homework without any help. I am free. I'm able to help you if you guys have any questions. So feel free to use me as a resource. Okay. I hope you guys have a good day. Remember, it is Wednesday. Okay, I'm going to have a hard time remembering that probably at some point. My days are jumbling together. Hopefully we can keep track of the days though. Have a good day.